All right, good morning. So I work with Dr. Richard this summer, and my project is using modeling to manage organic residues and maximize soil carbon benefits. Next slide.
Did it go to the next slide or no?
No. Okay. Okay. So basically we're using corn stover, trying to see what will happen if those crop residues are harvested from the field and converted to biofuels. Can we extract energy from these crop residues and still achieve strong soil carbon levels? Next slide. So basically with the fresh residue, do we want to send it through the composting mechanism? Do we want to send it to an anaerobic digester, or do we want to leave those residues on the field and see what happens in terms of carbon input and carbon output to maintain levels? Which method will we see looks like it's most promising with this model? Next slide. So with a mathematical model, allotting for soil carbon that's up, we use a 60-year time span. We have to allot for the humification rate. Humus is rich in organic matter. Also, we are looking at carbon input. We looked at 6 megagrams per hectare, 68% of that going through the digester, 81% of that for composting, and we still have to allot for the decay rate, which is 2%, which is prevalent in the Maryland and Pennsylvania, Southern Pennsylvania areas. Next slide. So with the methodology, when you look at the H or the humification coefficients, one of the reasons why you see it higher through the digestate and the compost is due to that respiration. You have that microbial matter in the soil. So that is allotting for those H values. Next slide. Okay, so looking at the simulation models and some of the trends and just some of the results that we're looking at. So you have the H values for the 100% fresh residue ranging from 0.10 to 0.20. And then in the second graph, you have the carbon inputs for the composting. So for the first graph, it shows that you have these carbon steady states that are being achieved at about 0.15. Now for the composting mechanism, you do not have H values that are achieving these quasi-steady states. You actually have a decrease in carbon levels. And so you are having more of this carbon reduction. So you don't have this balance of inputs and outputs. And that plays a role in understanding the quality of what's going on in the soil, what's going on with the environmental conditions with the carbon being released. Next slide. And so when we look at the third and fourth visuals here, for the digestate, you have a lower input compared to the second diagram. When the diagram was double, it shows promising results. You actually have this steady state of carbon compared to the digestate that was half that. So the big picture, next slide. Increasing the carbon input, continuing to support sustainable biomass production, serving as a means of renewable energy, playing a role in reducing greenhouse gas emissions by looking at the biomass production and using some of those factors in agricultural practices, and also continuing to study sustainable crop and livestock systems. I want to thank the CSTATs. I want to thank Dr. Richard and the lab, and I want to thank you all for the opportunity to present again.